Good morning, good evening, good afternoon, everyone. If you're from Eastern time zone like me, good night. But I hope you don't sleep yet. Because we have uh, building LLM applications using LabVIEW, a session to kind of talk about here. Um, so we have a few boring slides, but then we'll kind of open LabVIEW and talk and start coding a bit more. So I think that'll ease things up actually. But I'm running. Do you see the next slide actually?
Not yet. Yeah, now I see. Please go ahead.
Okay. So a quick introduction, actually. Myself, Navin Subramani. I'm a solutions architect, automation AI at Solitown, living in Boston. I'm a champion, a LabVIEW champion, CLA, CTA. I do a lot of Python coding, a bit of web technology, and generative AI as well. But my first love is always LabVIEW. So yeah, talking about love and LabVIEW, my wife is a LabVIEW architect as well. So we are one of the few LabVIEW couples out there. But she's not joining this meeting. I was not able to get her. She said, "No, I'm going to sleep." But I think I talked to her enough about these LLM libraries, so I think she can pass that. But yeah, that's about me. What you're trying.
Yeah, that's nice. So, hi everyone. Good morning and good evening. My name is Pranay. I am again from Soliton, having 7 years of experience in LabVIEW. Always love LabVIEW. I'm also a LabVIEW champion, CLA, CTA, and CPA. Looking forward to this session on generative AI, looking into some interesting stuff, building like agent applications using LabVIEW, not Python. It's today AI and LabVIEW for the next few minutes.
Yeah, definitely. So to kickstart it, right? So we are all LabVIEW developers. We build LabVIEW applications. We build LabVIEW applications for test automation, data collection, analysis, etc. And we build it for people, like people like engineers, scientists, developers like us, right? So who interact with the LabVIEW application to get the job done. How do they get the job done today? Is it because we also provide them knowledge, training on materials, user manuals, technical specs, so they actually use these materials and knowledge, and they can actually work with our LabVIEW application. This is how it kind of happens today, right? So whenever something goes wrong, how does people figure it out? um, People have to figure it out using the knowledge and LabVIEW application. And the primary reason is the documents, though they have the knowledge, they don't communicate with people. LabVIEW through user interfaces, it kind of communicates with the people, but it's not intelligent. So people have to figure it out, right? So that's kind of how it happens today. So the idea here is, how can we take the knowledge and combine it with LabVIEW applications so we can make the LabVIEW tools a bit more intelligent, right? So instead of user talking to like a dummy tool, they can talk to an intelligent tool. That's kind of the idea. And how do you make it? So using LLM libraries, you can actually take the knowledge, embed it into the LabVIEW application to make it intelligent, right? So this is more like a 30,000 feet level overview of, okay, where LabVIEW LLM libraries are used, right? It's about to make your LabVIEW application intelligent, kind of. So in the next 30 minutes, what we're going to do is we're going to show some demos about some example applications that we have built. And we are actually going to code it from scratch. Hopefully, things will work to show how to build generative AI applications like in LabVIEW, right? That's kind of the idea. Um, but Pranay, do you have any questions or you see any questions from the chat? Feel free to ask, or you can start showing a demo of a sample application.
Sounds good. That sounds interesting. I don't see any questions here from the chat, but let's get started with a simple, quick demo to see what we're going to build step by step in the next few minutes today. Right, so quickly bring in my screen. Please let me know when you can see my screen.
Yeah, I see my screen as well. So I think I should stop my screen. Is it? Stop sharing. Oh, I have stopped sharing audio and video. Oh no, I think there's stop sharing. Okay,
Okay.
now it's full screen. Pranay.
Okay. Sounds good. Thanks, Naveen. So yes, so like Naveen was saying, we can build some interesting applications in LabVIEW. That's what we have been doing for decades now, couple of decades since LabVIEW came out, and we have always been seeing it exciting when LabVIEW can talk to instruments, make some measurements, and then help us plot all the graphs and charts, log, and do all exciting automation stuffs. But there is always a question. Let's say we have a simple application in front of us. I start running it. It's about like validating a device. So, few questions that we usually get when start using an application is like it's basically like validating a device connected with some instruments and things. What values do we configure to the device? Like for example, here I have an voltage regulator. I need to give an input voltage. It generates an output voltage, as simple as it. But I have a power supply connected. Uh, Maybe the first few questions that we get is, okay, how do I know what is the input voltage range for this device? Yeah, interesting. So we generally go to our device data sheets, a bunch of pages. We read through, figure out, okay, uh, what is a proper value that I can configure. And then it doesn't stop there. We would have so many settings. Doesn't stop there. If something is not working good in our application, we again have to like reach out to someone else in the team, or we need to go through a bunch of documents, understanding and finding out the answer to it. But how about our application is a bit more intelligent in helping us find the answers? Today we'll start by looking at how to find the answers, but we'll just slowly progress towards what more, what beyond can be done using LLMs in LabVIEW. Right? We just don't want something just that answers us, but also something beyond what it can answer us. So I have a help button here. Once I click, I just see something called a chat. We can just always give some good names beyond this one, but let me say it's a chat. I just say hi. It's entirely LabVIEW application. We don't have any like Python anything running in the backend. It's just like LabVIEW talking to LLMs. It says, "Hello, how can I assist you today?" Let's go with a simple first few questions. I can just ask, "What is the input voltage range for this device?" Right? I just asked. Generally, I am at this point using OpenAI model, which may not know what is this device, but it was intelligent enough to say the answer specific to my own data. Right. So that is the first key thing. Now my LabVIEW application is acting on my own data, which we will see just in some time how you can do one by yourself as well. But it said, okay, interesting. If my input is between this range, it's good. So I can just go ahead, start configuring and working with my application. But now it said, okay, there were some issues in my application. It just prompted, okay, there is some, let me also do some more thing for you. Let's say I just turn on my power supply. It I had an error. Generally, in our LabVIEW applications, whenever we have an error, we see a dialog box prompting out, and then we go online looking for solutions to it in case if that is something we are not familiar about. But how about AI proactively looks into our application, events that are happening in our application? Example event is an error that happened just right now. It said the error that I got was uh, something went wrong, some resource not present in the system. My AI assistant says, okay, so to resolve this, open an Emacs and make sure you have this corresponding resource name available. That is interesting, right? Like I just make sure I just realized, okay, this particular slot to resource is not available on my system. So I just go ahead and then pick something. So I turn on my supply. Now I see my supply making some measurements, and then I'll also turn on my output. I'll just give some output. It doesn't just stop there. In case if my device or application is not working as expected, we have to troubleshoot that. My LDO, even though I'm sourcing 3.3 at input, it just gives me like 0 volt output. So I just need to figure out, okay, why is my device not working as expected? I can also ask, okay, why is my device not working as expected and is giving 0 volt output. So if there are knowledge enabled to our system on how to troubleshoot, it will help us making the process of troubleshooting much easier. So for example, now my uh, AI looked into my schematics or system information of my uh, current product under test, and then it says verify the input voltage by dev 1, but I was using dev 2. That's a mistake. So I just go ahead and let's try the first debugging. I said dev 1, turn on the supply. I see. Now I get the proper voltage. Some voltage, it's coming out. It's not as bad as earlier. It's not 0 voltage. So in this way, we can build applications using LabVIEW. A lot more can be done beyond what we are seeing here. We can play with images and pretty interesting stuff in LabVIEW with AI. So we're just going to see a detailed demo of how to build this agent, which can use this agent, which can act upon our own data and also use this agent to proactively listen to events in your application and give you or your customers suggestions on how to like take next good steps.
Yeah, I think what Pranay showed was a good example, right? So we ship LabVIEW application. We, as a, I mean, honestly, as an engineer, I don't like to write documentations. And I know the people, the engineers who use the applications, they also don't like to read the documentations, right? So we actually
Absolutely.
keep writing, and we kind of ship it out, right? But so idea is the Pranay took these data of your application and he fed this knowledge into the LabVIEW application. So user need not kind of read that 70, 80 pages of documentation. All they wanted is, okay, have a trouble, they ask, it kind of provides the insight that they wanted, right? It kind of provides them the compressed set of knowledge that they wanted on demand, always, right next to their chat. So that was an interesting application. So what I'll do is, so Pranay, do you have anything to cover before I?
No,
Um,
you can good. This is
okay.
good for me.
So what I'll do is I'll try to open a blank VA and show how we can actually develop this from scratch, right? Let me share the screen here again. Okay, I'm going to open LabVIEW. So uh, we will
Navin,
see
I
how
think you are just sharing your uh,
presentation. Sorry,
PPT presentation.
share screen. Not so used to this interface. Do you see
You
LabVIEW
can
now?
go to, yeah, you can go.
Okay. Okay. So what I'll do is I'll just open a blank VA. So when you install LLM libraries, um, okay, and you right click, go to the palettes, you have Soliton, you have LabVIEW LLM libraries, and you can pin it. So this is the LabVIEW LLM libraries that you have. It comes up with few APIs like models, vector store, agents, and UI. In this session, I'll focus on agents and UI. I'll keep the models and vector store at the end, maybe on a high level, because that goes into more GenAI development, but focus on agents and UI to kind of start with. But you open any of these palettes, you will find a typical set of APIs, something to instantiate your models, close your models, connections, something to instantiate your vector store, destroy your vector store, and then probably get read from your stores. If it's an agent, Pranay showed a good agent. It's a question and answer agent. I mean, okay, before that, what is an agent, right? Agent is anything that has an intelligence um, that can do one thing really well. It's like your solid principle. You have a class does one thing really well. You can imagine agent does one thing really well. Like if this does question and answer really well. You might have an agent that does talk to a waveform and says issues with the waveform. You might have an agent that books tickets on Expedia. So agents are nothing but um, an intelligent system that does one thing really well. Here we have an agent that does question and answer, like what Pranay showed. So that's something that we kind of develop out of box. But you guys can also create any agents that you wanted, custom agents for your application. User interface is something that helps you interact with these agents. um, a very common user interface for GenAI application is a chat user interface, because you can actually talk in a natural language, right? So we have a chat interface. You can instantiate, destroy, add a message, typical APIs that you have to instantiate and use a chat UI. So in Pranay's up demo, he showed a chat UI integrated into his application, and he showed a Q&A agent. I'm going to use these two to kind of develop something from scratch. Um, you might have a your own frameworks, custom frameworks, or you might use JK State Machine, or you might use DQMH, you might use actor frameworks. You can actually drag and drop these things into those modules, create an actor, which is like an AA actor, or create a DQMH engine, which is like a thing, and whatever that you wanted, right, using the API. Or to kind of have a high level starting point, we actually created a template with JK State Machine, um, that kind of comes up with all these APIs already dropped in. So I'm going to start with that for now to save some time. So I'm going to just say create uh, a LabVIEW LLM simple QA agent state machine. It's a long name actually. Again, it's an open source project. I'll kind of point you to where this libraries are maintained actually. In a bit, you can actually go and improve this, create more capabilities on top of it. But uh, yeah, we can do whatever you wanted. So let me close this. My first window is the other window, so it's kind of opening up in a different window. So I'm going to pull this here a bit. So what it does is it created me a simple LabVIEW UI with a chat interface in the right side. It's a HTML based chat interface, a simple string control where you can ask questions, and a button where you send it's asks the question actually, right? So the goal is like, internally we were talking like every LabVIEW application that we develop hereafter has to ship with this chat interface in the right side, right? That's something that we have, something like an internal target for us, but it'll be interesting. So again, a simple template with the chat interface in the UI. If I open the block diagram, it opens in the screen. I'm going to pull it in here. So it's a JK state machine again. I'm going to move this palette to the right side a bit here. Okay. Um, Nothing crazy. Three states for agents: an agent initialize, agent close, and agent ask. All right. And three case for user interface: initialize your user interface, uninitialize, close, and then update your chat message. Right. Very basic, and each has the APIs called in it. So I'll first, I mean, the user interface is very simple. It takes a subpanel reference in, so that whenever we run it, it loads the HTML UI in the subpanel, um, and then destroys. And whenever there's a message, it just add the messages to the user interface. Agent initialize. When you This agent requires a large language model as an input, as well as a vector store. I'll kind of talk about the large language model a bit later in the session, but assume it requires one of the large language model. I mean, at this point, as you can see, OpenAI is configured. So it takes the OpenAI as an input, initialize the agent, and whenever a question is asked, question goes in, answer comes out. We are asking the model, right? A very simple thing. What I'm going to do is just open the front panel and run it. It's going to throw an error because I want to do uh, I wanted to save this actually, so it can actually load my OpenAI keys from the background. So let me stop this here, or stop this. I'm gonna save this. Control yes. Okay. So I tested this 4 times before the session from morning. So I'm gonna say test 5. Hope it works now. So okay, I ran it. Let's see. I'm just gonna say hi. Uh, no, something is not right.
I think your keys are getting picked from the main application instance. Maybe you should use your project
Oh,
application instance.
you're right, Pranay.
Yeah. So we didn't want to put the keys directly into the software, as you all know. to the audience. So what we created is we created a simple library. So whenever we run this VAs, it will pick the OpenAI keys from the project instance. So now when created the VA got created in the main application instance. Maybe in our upcoming releases, you would see whenever a new VA is created, it would automatically get added to the
Yeah,
project application instance. So you don't
I think
have
I
to
think
face all these issues. Yeah.
LabVIEW is crashing on me. Let's give it a second to crash it. I don't know if it'll survive, but what do we do? Should I kill?
Yeah. Let's go.
Oh no. I mean, my
Did
LabVIEW
it
does
work?
this. When I say should I kill it, it starts working actually. I think there is an intelligence. Let's see. Let me open the VI now. Hmm. I think I ought to blackmail our applications a bit. Okay. Hopefully. No, not my day. Let me just see. Hmm. I think it's slowly getting there. Oh, my machine is acting. It's slow today. I'm gonna say hi, please. Okay, it's there, guys. It's working. Not as I expected, but it's there. So it kind of gave me a response hi. So I can ask questions like, um, "I'm sleepy. What should I do?" You can ask anything that you wanted. It's a large language model. It answers anything that it wants. It gives me take a nap, whatever it is. But like I can say, I want to code. Uh, Code LabVIEW. You can kind of talk anything about it because there's it's just pure large language model that I'm actually interacting with at this particular point, right? So there's nothing like your intelligence in it. It kind of gave me an idea about, okay, I want to code LabVIEW. It understands the context. It knows that I'm sleepy and I wanted to code in LabVIEW, and it kind of gave me some details. But anyway, I'm going to stop this application. You get the point, right? All I did is added three cases and probably like three APIs for initializing the user interface and three cases for agents and like initializing, closing agents and asking question. And you have a chat bot in your lab application in the right side, right? Purely. Now let's actually start coding something relevant. I have an application. I have a made up application. So I'm going to drag and drop uh, an imaginary application into my LabVIEW. So imagine this is my application. I'm not coding any application. This is an image from ChatGPT, but the imaginary application that we are going to have and work with it today has three pumps, have a water tank. It throws water into your tank. It has like a pressure flow sensors and it has a graph, right? This is like a my application that I have today. Now, um, I wanted to start asking questions about this particular application, right? Um, Now, my agent does a Q&A. I'm going to open a block diagram. I'm going to show this particular part specifically. But whenever I ask a question, it's answering based on the model data, right? So we have two options you can toggle with. Either you can ask your model or you can ask your data, right? It's a small toggle. I'm going to move from ask your model to ask your data, right? Now, whenever I ask a question, instead of the answer coming from models pre-trained knowledge, which is like OpenAI trained knowledge, it's going to answer based on my data, actually, the data about
Interesting.
this particular application. All right. Um, Now, your question is, oh, all you did is just swap, ask your data, but where did you tell your data, right? So that's where this agent initialize comes in. During agent initialize, we have this array of string control. It's an array of source. It's just expecting you to provide source as an input, right? Today I have the documentation about my application on GitHub. So it's a GitHub public repo I just kind of created for GLA. I said this is my application, and I asked ChatGPT, can you give me a, a user manual for it? It kind of made up an application overview, system components, pumps, data, storage tank specifications. graphical user interface experience, whatnot, right? It kind of gave me an user manual for my imaginary application, right? So I wanted the system to answer based on this imaginary user manual, right? It could be your application user manual, but at this particular point, it's an imaginary user manual. So all I'm doing is I have to copy this link, Control C, um, and then come here and do a paste. And then I'm just gonna open the front panel, let it save. I think my machine is pretty slow today. Um, okay, it saved it. And I want to click run. Okay. Now what it happens is when the application starts, it's going to pull the data from my GitHub um, and do some data preparation. So that it kind of prepares my data. So it's kind of a one-time process. You can do it every time you want it at the start of the application, or you can kind of choose to skip it if you want it, right? But essentially, it starts embedding. So let it embed um, the data. It takes like a few seconds to do this. Um, Once this completes, let it complete. All right. Once it embeds the data, my application, my chatbot is having that knowledge to start answering questions based on the data that I have in the GitHub, right? Now, I'll just check if it's alive. I always ask hi. If it responds back, it's live. Hey there, can I help you today? Great. I'm going to ask it back. What can you help me with today? Help uh, me with. Um, so it's going to, based on the knowledge it has, it's going to say, oh, I have information about fluid management systems along with your contact information. How can I do this? It's like user manuals and technical documentation. So that's fine. Um, what I want to know is what is the maximum pressure for the pumps? And it comes back and says the maximum operating pressure for the pump is 10 bar. Because if I go back to my documentation on GitHub, somewhere um, under pump
It was
specification,
right there. Yeah,
yeah, it
a
should.
little.
Yeah, I couldn't see Pranay.
A
Oh yeah, 10
little,
bar.
no? As
Yeah,
yeah, maybe.
maximum operating pressure is 10 bar. Okay, great. So it was able to kind of find it out and answer it. Again, I can go on asking about, no, I have an issue, like who should I contact if there is an issue and whatnot. It keeps answering. Now all I did is uh, again, still it's a three case structure coding, but then I just pointed it to my specification data, so it was able to kind of answer. Great. It also gives me the imaginary pump company. I mean, truly, it's. I mean, I said it's an imaginary pump company is the name of the company, so it is right, right, and an email for it. So this all is good, right? So, but everything that you see here now um, is very reactive, which is like I still ask the question, and it provides me the response, right? But you can actually take it to the next level. You can make the system a bit more intelligence, that is a bit more proactive, right? Whenever there is key events that's happening in your application, you can make the chatbot respond to that key events. For example, a key event may be like an emergency shutdown, or it could be maybe that there's a calibration record, your data is off, or very common event is an error event, right? When there is an error event, you have to have the bot proactively tell you what happened, right? Because most times, like people find an issue, they come to us telling, hey, this happened, right? But what if there's an intelligence sitting in my application which can actually help answer it, right? So let's try to simulate an event and code a little more to see how we can actually make this bot respond to this event. Now, I'm going to just create a boolean here, which is going to trigger an event. I'm going to say simulated error event. Um, I think I have to restart my LabVIEW. It's pretty slow. I can sense it. Not sure if it's because I'm sharing my screen, but anyway. So I'm going to color this thing to red and color this guy to green. Just This looks like a green. Okay, I'm just going to drop it here on the pump, um, right? And then let it save. Even a save takes a bit of time. Okay. No, okay. I have a control here, change to control, and I want to create a simple event. All right. Um, I'll just duplicate the panel course. So I have this bad habit of duplicating from something, not creating from scratch, because I get something for free in the screen. Um, just ensure I delete this. All right. So whenever I click a button, all I want to do is like simulate an error, right? So I'm going to just drop in a error cluster here, say true, and I'm going to just say error code. It's a custom error, so 8903, and I'm going to have a message. I dropped it on a pump, so I'm going to say uh, pump 3 failed, an error that's useful for no one. Um, so when I run the VA now, um, I, I should not save actually. Every time I click save button, it just spins up for a while. Okay, so whenever I run my VA and trigger an error, it comes to the error handler and pops it up. Right. Um, Let me quickly test this. But before that, I'll just um, disable loading this data from the GitHub. Um, like every time pulling the data from the GitHub, I just disabled. So it just uses the data that I pulled from the last time. So now I'm running the application. Let me quickly test this thing out. Um, all right. I think the system is up. Uh, as usual, I'm going to ask, hi. I think there's a problem. It it takes a bit to initialize something in the backend, so I'll give this a time. If this continues, I will probably like restart my LabVIEW. Um,
Yeah.
okay, first time it's something is taking time to load. Anyway, but whenever there is an error, the point is I get an error message. Okay, great. Now I'm going to make this a bit more intelligent, which is what I'm going to do is um, in this error handler, I'm not going to throw a pop-up. Instead, let's actually trigger AI to respond based on what the error is. So under models, we have this message API. So instead of creating a text message, I'm going to create an error message. I'm going to feed the error in to um, to the create message. I'm going to just make, and then let me just bundle this so that bundle this into the latest message. So this actually goes to the agent ask. All right, done. Now, whenever error comes, it creates an error message. Very simple thing. I'm going to one display that in user interface. Two, going to do an agent task. So to display in the user interface, all I want to do is call UI update chat message. So error handler UI update chat message. To trigger a agent task, um, I'm going to do agent task. Now, whenever there's an error, what it does is it just adds a message into the system, displays it in the user interface, and asks my agent about this error, right? Because it's a create error message event. But the problem is, I know um, I don't have any details about it in my data, about the error in my data, right? Because it's a user manual. But I do have a text file in my machine. So I'm just opening my logs. I have a text file here that contains list of errors that happened in my application in the past, the reason for it, and how do I typically fix it, right? It's, you can think like an error database, right? I kind of have it in my system. So what I'm going to do is shift right click This is a cool thing that I just learned recently. I can do a copy as path and then go to the agent, initialize, and I'm going to, along with the GitHub link, I'm going to put this text link from my local machine as a one more data source. And I'm going to say, don't skip the loading because there's a new data. Load this thing in. Now when I run my application, let's try. I want to save this to be sure. And then, okay, run it. I think, sorry again, it's going to take those few seconds to get ready. And then you will see the loading of, like downloading the data from GitHub again, pulling the data from the local machine and getting the bot ready, right? It's going to take the few seconds at the start. I mean, once I do it, I mean, it's in the cache. So you can actually skip from the next step. And then this loading, it should not kind of take this much time. But anyway, it starts to embed the data. Mm,
So where does this data get stored, Navin? So, and what kind of
that's a good
support
question.
could you answer?
So all these data are stored in my local machine in a vector DB. So vector database is kind of a database that takes all the information. Vectorize. You can kind of think it it stores information in an AI friendly way, right? In
Mm,
numbers, so that AI can understand your data. And there are a lot of vector stores out there. Um, there are vector database that works at scale. Since we are only using it for one application, that to local, you don't want scale, right? So you can use simple vector stores that's lightweight. Currently the vector store that I'm using is Quadrant, but there are other file-based vector store which does not require any installations kind of it as well, right? That you can do. um,
nice.
and I'll actually show you the libraries for the vector store because it's a plugin based system. You can kind of create vector database support for any vector databases. Today we have support for Quadrant, right? All you do is just create a class, inherit from the base class, and override certain APIs to create your own vector databases, right? But we support Quadrant at this particular point. Um, I'll just check. Hello. Yep, the guy is there. So now I can actually trigger the error. So once I trigger the error, I mean, once the error happens, error event happens, you can see the bot activates and then it says, hey, I see there is a pump 3 issue. It could be because of internal motor fault or communication failure with the pump controller. You may want to verify wiring and control panel connections. Okay, I'm going to ask, how do I fix it? And it's going to, again, it has the knowledge. It's going to look into the knowledge and say, okay, you have to fix, like, persist, you may need to replace your pump controller, baby. That's typically how we fixed it in the past. But now you kind of get the point, right? Now the idea is you can actually trigger these things on any events and you can have a communication based on your data. All I coded is, again, I did not code any new cases. It's probably like 3 cases for agent initialize, close, and ask. All I said is, what is my source to the agent initialize, and it takes care of the rest, right? That's on a high level. Now, um, I was expecting a question from the chat, which is, "Hey, you're using OpenAI, but my data has to be secure. Uh, in my company, we have our own AI policies, right? How we want to use it, but how can I use it using probably local large language models? How can I ensure the data sits within my computer, right?" Uh, so again, if that's something that everyone asks us. So typically, the companies, organization, I mean, they partner with either like one of these three big cloud vendors like AWS, Azure, or Google GCPs, and they get this Azure OpenAI, AWS Bedrock, or Gemini large language model from these vendors. If your company does not have a, I mean, if you don't have an AI policy where you are approved to use either OpenAI or Azure OpenAI or Anthropic from Bedrock or Google Gemini, and you are only approved to use local large language models, we have support for something called Olama. So this is a large language model, a quantized model that you can actually install in your computer if it has like a GPU. My computer has a GPU. It's like a GeForce RTX, I think 4070. So I can run a quantized model in my computer. If not, you might have a server in your company where you can actually run this as well, right? So we have plugins for all these different large language models. We have a suite of commonly used large language models. So what I'll do is, just to show you a demo, I'm going to switch from OpenAI to Olama. That's pretty much it, right? I'm going to delete all the input, like it's not going to be for many, right? So I'm going to pick a model. So in my computer, let me just quickly confirm what's the model that I have. Let me open my command line. Oh, I think we have only 5 minutes more. Okay. Um, let me try to be fast here. Olama. So the list of models is Olama list. I just need to know the spelling of my model. So it's going to be Llama 3.1 latest. Okay. So what I'll do is I'll just say Llama 3.1 latest. I think I'm right. Llama 3.1 latest is my model. So yeah. Oh, did I really change a different one? Oh yeah. But I think I think given the time, I'm gonna skip it because I know it takes few seconds to run. All I have to do is just feed this in a right control, um, and tell the server where it's running. In my case, it's running in a local server, so localhost works. And then when you run it now, it actually runs it with your local large language model. I can prove it by disconnecting the internet, but the call gets disconnected, so I'll probably not do that. But um, you can trust it, right? Or you can try it offline as well. But that's kind of an idea, right? Um, you can now have an agent that's agnostic of models. You can actually use like online SaaS models, or you can also use local large language models and build your agents and applications. That's it next year, I think. Anyway, this on a high level, we want to show how do you code or create agents, use agents from scratch to develop an application. Um, I will let it run. It loads. You can trust me. So what you have seen now is we had agent collections and user interface collection, out of which we had one agent. We showed one agent, which is a Q&A agent, and LabVIEW chat user interface. Again, it's an open source thing. There's a lot of things that we can improve on here. We can optimize a lot. We can improve the performance, whatnot. We can make the chatbot looks very cool as well. You can show the links of the documents in the chat interface as well. So all these things are like up to us to kind of improve based on the priorities. But we showed you one example of an agent and a user interface. You can create your own custom agents as well. And we've also seen how an Q&A agent can work in two modes, which is an ask your model mode and ask your data mode. There is a lot of things that this library does. We haven't gone into the models and data side of it. Um, we just showed you from oh, here's an agent, how a LabVIEW developer uses an agent in an application. But if you are interested to create your own agent, you might need some basics of generative AI. At that point, you would need a bunch of models, and you need to have libraries that prepares your data to build a good agent. So um, we have some libraries that parses data and provides it to the agent, as well as a suite of model libraries, abstracted model libraries. So you can actually swap data, swap models, and make your agents a bit more agnostic. So this is something that we will try to see how we can actually cover this probably in a different sessions, as it bit involved actually. So that's it. All this is open source. It's on a GitHub. You can scan the QR. It takes to your GitHub. You can actually start downloading and use it, trying it out. Or I think there has to be a lot of contributions, because we know that a lot can be improved. Honestly, we are using it day to day in certain applications, and we feel that can be more features added, more data sources added, and things can be much more efficient. So here's a link. Please contribute, or if you wanted to use it, feel free to reach out to us, and we'll happy to help here, right? And reach out to us. I think I not add our details in the slide. Sorry, or I did not take the latest. So Pranay and me, uh, Navin, Subramani, and Pranay, you can actually go to LinkedIn, uh, search us, or we'll put our links here. So feel free to contact us. I think LinkedIn is one good spot where you can reach out to us, um, and we are happy to kind of help you. Or you can even have a feature requests or have an issue. You can actually go to the GitHub link, uh, drop an issue, and tag us, and we are happy to kind of help see what you need and help you adopt this, right? So that's pretty much it from LabVIEW LLM libraries. I think in 45 minutes we were able to build something from scratch and show you. Hope you enjoyed the session. We'll kind of stay back for a few minutes. If you had any questions, feel free to. But thanks for joining, guys. I think one had a suggestion. Kill, kill, kill. Yeah, I should have. Okay, could you give me an example where you have used LLM for the customer? Yeah. So okay, I mean, at Salton, we build a lot of LLM applications, but in Python and web technology stacks for our customers. Um, there are a good set of use cases like, you want to generate test cases for your testing. You need to kind of create some data analysis or report. Right? We actually use these LLMs actually, but primarily within LabVIEW today. Uh, uh, the other use cases are like, works at scale, works on cloud for multiple users. With LabVIEW, it's always on the bench. I have an engineer who's trying to solve some problems on a bench. How can an intelligence sitting in my bench can solve the problem, right? So that's kind of an use case. So mostly it's going to be whenever there is an issue with my system, hardware, software, uh, anything. How does an user or engineer has to react, right? So we kind of have an LLM intelligence sitting there guiding the users, right? Guiding users through calibration routines and whatnot. So these are some of the use cases where it's useful within LabVIEW, the test and measurement applications, guiding test engineers, operators in their day-to-day job, right? Kind of. So yeah, thank you, Darren. Thank you, everyone. Thank you, Casey. Thank you, Chris.